Hello everyone, welcome back to Engineer Comrades. So in today's video, we are going to build and understand AWS Transit Gateway step by step right from the scratch. So we'll have two VPCs, VPC A and VPC B. This is our VPC A and VPC B. In VPC A, we'll launch two EC2 instances, one in public subnet and another one is in private subnet. In VPC-B, we will have one more EC2 instance in private subnet. We'll first test how these instances communicate without a transit gateway, and then we will deploy the AWS Transit Gateway to connect both VPCs. You will see how the routing changes, and we will verify connectivity using SSH and ping all in real time. We'll also open SSH and ICMP in our security group just for demonstration purposes. And before we start the lab, I'm really excited to announce that we will be creating an entire AWS Solution Architect Associate hands-on series here on the channel. So if you are preparing for AWS certifications or want to get practical cloud experience, make sure to subscribe to the channel and hit the notification bell. You don't want to miss upcoming videos. All right, let's jump straight into the AWS console and start building our transit gateway step by step. We will be referring back to this architecture diagram again and again while creating the lab. So let's begin. So let's go ahead with our step one, which is create two VPCs. One is VPC A and another one is VPC B. So let's start building it. This is the AWS console. Let's search for VPC. Otherwise, we are getting the VPC option here only. I'll click on VPC. Click on your VPCs and create a VPC. I'll click on it. VPC only I'll go with. Name, let's refer the diagram. It's VPC A. I'll put VPC A. CIDR blog, let's again refer to our diagram. It is 10.0.0.0/16. Tenancy will go with default only. I'll hit create VPC. So one VPC is created. You can see VPC A. Let's go ahead and create one more, and this time we'll name it VPC B. VPC B, and the IPv4 CIDR block is 10.1.0.0/16. We'll put the same 10.1.0.0/16. Hit on create VPC. So we are done with our first step. We have created two VPCs. One is VPC A, another one is VPC B with the given CIDR blocks. Now let's go ahead with the second step, that is create subnets. Let's hit the AWS console again. We'll go to subnets and we'll start creating subnet. First of all, you have to define where you are going to create the subnet. So first, we will be creating the subnet in VPC A, and as per diagram, we would need two subnets, subnet A and subnet B. In subnet A, we will be putting our public EC2 instance from where we will be SSHing from the outside to this jump server to access all these servers, this first one and this second one server. So let's select VPC A, the subnet name. Let's refer the diagram once again. Subnet, we will put subnet A, subnet B. Okay, I'll put the name like public subnet A. I'll put public subnet A. The CIDR block is 10.0.1.0. I'll put the same 10.0.1.0/24. Let's just verify it. It's 10.0.10/24. So we are good with the first subnet. We'll create it. So right now we have created one subnet, and this is in this under this VPC. The CIDR block is 10.0.10/24. Let's create another one. Let's go with VPC A again because we have to create one more subnet. This time we'll name this subnet as private subnet. I'll put private subnet. Let's go back and then check what we have named. Okay, public subnet A. So we'll create private subnet A. Okay, I'll name it as private subnet A. And the CIDR block again, refer the architecture diagram. It's 10.0.20/24. We'll put the same 10.0.2.0/24. So we are good with the second subnet as well. So till now we have created two subnet for VPC A. Now we have to create one more subnet for VPC B. Okay, let's go ahead and create that as well. We'll create one subnet. We'll select the VPC. This time we'll select the VPC B, and the subnet name will be private subnet. We'll name this B because this we are creating for the VPC B. Okay, the subnet details is 10.1.1.0/24. We'll put the same 10.1.1.0/24. This is the correct subnet CIDR block notation. I will create subnet. We are done with our second step. We have created two subnet in VPC A. One is public subnet, another one is private subnet, and one for VPC B, the private subnet. You can see the CIDR details as well. So let's go back and check what is our next step. So next is create and attach internet gateway so that we can SSH to this. We'll go to internet gateways. We'll create internet gateway, or let's go with the IGW. Okay, so we are done with internet gateway creation. You can see it is created, but we haven't attached it till now. You can see in the diagram the internet gateway is attached to VPC A. So let's go ahead and attach it. I'll go on action, attach to VPC, and will select to VPC A, attach the internet gateway. So we are done with the internet gateways as well. Next is create security group that we will do while creating EC2 instance. But before that, one step that we have missed is to check the route tables. In the route table, we can see this is the default route table that AWS has created for us, but we'll create our own route tables as well. I'll put RT VPC A, okay. This is for the first VPC. We'll go to route table again and we'll create one more route table. And this time I will create RTC VPC B, RT VPC B, okay. And we'll put it for VPC B. We'll create the route table. So right now we have RT-VPC-A, RT-VPC-B, two route tables, but we have three subnets. So let's create one more route table for VPC-A because in VPC-A we have two subnets. So let's create one more route table, and this time we'll put A, but this is for public subnet. Okay. We'll select VPC-A and we'll create route table. So we are done with the route tables as well. We have, let's sort it. We have all three route tables with us for each subnet. For VPCA, we have two subnets. One is for private. Let's name it private as well. Okay. One is for the private subnet, one is for public subnet, and another one is for VPCB. Because in VPCB, we only have one subnet. So we are good with one route table. So we are done with the route tables as well. Let's head back to our steps. So we are done with the create two VPCs, create subnets, create and attach internet gateway. We are done. Let's go and create EC2 instances now. Search EC2, or I'll go here and we'll search EC2. Okay, let's click on launch instance -a1, and this is our what? Public EC2. Okay, we'll put public. Let's copy the name as well. Okay, go ahead. We'll leave these to default only. Linux image, Amazon Linux image. We'll go down instance type. We're good with T3 micro. It's eligible for free tier. Key pair login, I already have created one, but you can also create it. It's very simple. Just click on create, name your key pair, and then select .pam format, create key pair. But ensure you save those key pairs, because if you have lost the key pair, means you have lost the EC2 instance as well. Okay, so I already have. I will not create it. I will go with it. Okay, this section is important because now we have to make the changes. This EC2 will live in subnet A and under VPC A. So what we will select VPC A, and the subnet will go with public subnet. Okay, we will be SSHing to this server from outside. So we'll enable auto assign public IP. Click on enable. So this step, create security group, will do it here. Okay, I will select create security group, and the name will stick with the architecture diagram, that is TGW demo. I'll put TGW demo SG. Okay, SG is for security group. So one rule is SSH on port 22 from anywhere. Okay, I'll add one more group. Okay, this will be for testing purpose, so I will go with all ICMPv4. Okay, range is from anywhere. If you want, we can also put description like this is for ping, this is for SSH. Okay, so we are done with that as well. I think we are good. We just need to click on launch instance. So we are done with one machine. We have to create two more, one in VPC A and one in VPC B. So let's create EC2 instance in VPC A, but this will be in private subnet. Okay, so let's go to instances. We'll click on launch instance. Name we will put as private. Okay, I'll leave the setting as defaults. We'll go down. We'll select the key pair and we'll change the network settings. This will live in VPC A, but the subnet will be our private subnet, right? This is the private subnet. We'll select the existing security group because we already have created. We'll select TZW demo SG, and we are done. Okay, we'll hit launch instance. We are left with one more EC2 instance, but that will be in VPC B. So for now, let's check if our instances has been created or not. You can see EC2A1 public has been created as well as private has also been created. One has got the public IPv4 address, another one will not get the public IP address. So we are good with all the EC2 instances that we have. Currently it's in running state. Let's verify one machine. It should be in private subnet. You can see the private IPv4 address is 10.02.111. Let's verify 10.02. Okay, so this is in the private subnet. Let's check the public one as well. I'll click on instance ID. You can say its private IP is 10.01. It's 10.01. So we are good till now. We'll create one more instance, but this time this EC2 instance will live in VPC B. We'll put the name. Let's change it to B1 and private. We are good with the Amazon Linux image architecture. We're good. Instance type T3 micro. I'll change the key pair, the network settings. We'll go and change it. This time, this machine should live in VPC B, and the subnet, we only have one subnet, that is private subnet B. We don't need auto assign public IP. But when you will click on this one, select existing security group, you will not get that security group that we created because it was created for VPC A. Okay. So what we'll do, we'll create the similar security group. I will hit TGW. We'll create security group TGDW hyphen demo, and I see this is the name. The same thing again. We already have one rule for SSH. We will create one more rule that will be for ICMP. It should be allowed from anywhere. Okay, so we are good with it. Launch instance. So right now we are done with this step. We have also launched our EC2 instances. So now let's test connectivity before the transit gateway. Okay. So right now we have all the three EC2 instance. When we'll try to ping this machine, we should be able to ping it. But when we'll try to ping to this machine, it should not happen because this EC2 instance is a different VPC altogether. So for enabling that, we will be putting in a TGW, but let's verify it before the transit gateway. Let's go ahead to instances. Let's see if we are ready with our all the instances or not. So it's in running status, but the last one is still in initializing phase. So for that time, let's go ahead to our EC2 one instance, click on connect, and we'll connect to it. Okay. You can see we are not able to connect to this instance. What could be the reason behind that? The reason is that we haven't changed our route table. Okay. So we'll go to route table. Okay. So we have one route table, that is RTVPCA private, public. Okay. So let's go with the first one. We'll go with RTVPCA public, subnet association. Okay. So this is for public subnet, right? This route table. So we'll hit edit subnet association and we'll hit public one. Okay. We'll save association. We'll do for all these route tables. We missed this step earlier. So we are done with this route table. We'll go for the RTVPCA private. Again, hit edit subnet association. We'll go with the private one. Save association. Okay. We are left with the last one. This one is for RTVPC B. Okay. Let's go. Subnet association, edit subnet association, select private subnet B, save association. So we are associated our all subnet to the correct route tables. Now let's go to the route table A, that is RTVPCA public, and we'll check for routes. We'll click on routes. You can see these route table currently have only one route, which is local one. Okay. So nothing can go to the internet. We'll add one rule here. We'll put anything, the default route. Okay. It should route via where? You remember we had created one internet gateway. So it should route to our internet gateway. We'll select internet gateway and then IGW, the internet gateway name. We'll hit save changes. Now our EC2 connection should work. Let's go. So now when we'll click on connect, it should get connected. Okay. Let's connect. Now you can see we have connected to our EC2 instance. Okay. Let's verify the connectivity first. Let's check the IP address of this machine. This is 10.0.1. Okay, it's in VPC A and public subnet. Okay, so just for remembering it, I'll put 10.0.1.211. This is our IP. Okay, what we will do, we'll check the IP address for other machines as well. Okay, let's go ahead, click on instances. We'll go to instances and let's check the IP address of our EC2 instance, which is in VPC A but in a different subnet, private subnet. Okay, the instance, and this is the IP address. Okay, let's verify if we are able to ping it or not. Ping the IP address. You can see we are able to reach this server. Okay, but let's try to ping this server, which is in another VPC. Okay, so let's go back. We'll go to instances and we'll check the IP address of EC2, which is living in another VPC. Okay, this is the IP address. We'll copy it and we'll try to ping it. It should not ping because this is in a different VPC. You can see it is not, we are not able to reach to that EC2 instance. That's where the transit gateway comes to the picture. We have to attach one transit gateway between these two VPCs that will route the communication from VPC A to VPC B. So let's go and configure that one as well. We'll create an transit gateway first. Let's go back to the console. We'll search for transit gateway. Here we can see transit gateways. We'll click on transit gateway. We'll create one transit gateway. We'll stick to the name, that is TGW demo. It's TGW demo. Description, we're good with it. Configure the transit gateway. So these are the default settings. I'll try to explain a few to you. So default route table association. So whenever the transit gateway we put between two VPC, so these subnets will feed into the transit gateway automatically. So that is this option, default route table association. So automatically associate transit gateway attachment with this transit gateway's default route table. Okay, and this default route table propagation, this is what that our transit gateway let no other VPCs that we have this route. It will send the route to VPC B as well. So this is called default route propagation. So automatically propagate transit gateway attachment with this transit gateway's default route table. So we are not going to change anything here. Transit gateway CIDR block we also will not change. Just hit create transit gateway. So our transit gateway is currently in creation process. You can check the state. It is still pending. So it is still in pending. It may take 2 to 3 minutes for transit gateway creation. In the meantime, go back to our architecture diagram. You can see we are left with one more step, that is attach VPCs to transit gateway. So let's go ahead and we'll get this option, transit gateway attachment. We'll click on it. We'll create transit gateway attachment. Okay, we'll put TGW1 transit gateway. This one we have created. I will select this one. VPC, the attachment type. Currently we are dealing with VPC, so we should select VPC. Select a VPC ID. So first I'll attach it to our VPC A. So first we'll attach VPC A to our transit gateway. So that I have done it here. I'm attaching VPC A. Okay, and we'll hit create transit gateway attachment. Right now we have attached VPC A to the transit gateway, but we also have to attach VPC B to the transit gateway. Let's go ahead and we'll create one more time, that is TGW. I'll put 2 The ID we have selected, attachment type is good VPC. This time we'll attach the VPC B. Okay, so we have created two transit gateway attachments. We have attached our both VPCs to the transit gateways, and now you can see our transit gateway is available, but the transit gateway attachment is still pending. So we have to wait till the time it is in available state. You can see both the attachments are in available state. So now let's check the connectivity. It will not work. And why it will not work? I'll explain you that as well. You can see the pings are still failing. So why it is failing? It is failing because we haven't updated our route tables, right? Remember, we created three route tables, but still the route table doesn't know where to go, right? For this subnet 10110, the route table doesn't know from where, which path it should take. So we have to create route in the routing table as well. So let's go ahead and create. So first we'll be creating in the public route. Okay, you can see I'll put route table, will add a route. Okay, and the route table should, what should be the route table configuration? What should be the destination subnet? Destination subnet should be VPCB's CIDR block. Okay, 10100/16. We'll put 10100/16. Okay, and for this destination, our route table should use what? Transit gateway. Select the transit gateway. We are done with one route table. We'll quickly go and we'll do the same for our private subnet as well. We'll go in private subnet, rather private route table. We'll hit edit routes. We'll add one more route. I'll put 10.1.0.0/16. It should be routed via our transit gateway. Save changes. So currently we have updated our two route table. One was for public subnet A, another one was private subnet B. So these EC2 machines now know how to reach VPC B. Okay, 10100 subnet. But this EC2 instance still doesn't know how to go back to our VPC A, that is 10000. Okay, so what we have to do, we have to update this route table as well, and will give a path that how you should reach for this destination. Obviously that should go through the our transit gateway only. So we'll go back, we'll go to route tables, and we'll update this route table. Click on routes, edit route, we'll add the route. This time we are making changes in this route table. So the destination will be 10000. I'll put 10.0.0.0/16. This time also our path will go via transit gateway. I'll select it. Okay, and let's go back to our ping. You can see it is still not working. Okay, I'll go and hit save changes, and let's see, the pings have started now. Let's go back to our diagram. So we have updated the route tables and we have tested the connectivity as well. And that's it. We have successfully set up and tested our AWS Transit Gateway. We started with two isolated VPCs that couldn't talk to each other. Then after attaching both the Transit Gateway and updating our route tables, we saw that the instances across VPCs could communicate perfectly through the Transit Gateway. This setup is a perfect example of how Transit Gateway simplifies multi-VPC networking. Instead of managing multiple peering connections, you should get one central hub that scales easily across accounts and region. So we are just getting started. This is part of our upcoming AWS Solutions Architect Associate hands-on series. In the next videos, we'll cover topics like VPC peering, Route 53, load balancers, auto scaling, and lot more. Thanks for watching, and I'll see you in the next lab video. Until then, keep learning, keep building, and stay cloud ready.